Welcome to Algebra 1, Unit 5, Lesson 5.5, Direct Variation. This is Mr. Pilarski taking you on this journey today. We're going to continue our work with functions in Unit 5, and the work's going to continue with the direct variation. A direct variation is a function. It's not just a relation. And we're going to take a look at the definition to get started here. The definition of a direct variation. A function in the form y is equal to kx, where k is not equal to 0, is a direct variation. The constant of variation for direct variation, k, is the coefficient of x. The variables y and x are said to vary directly with each other. Let's first talk about this equation here. This is the form of an equation that's a direct variation. This equation is solved for y because the y is by itself. Y is equal to k times x. Now, k is the constant of variation. That implies that k is going to be a number. An example of an equation that's a direct variation would be y is equal to 1/3 times x. This is a direct variation. This is in the form y is equal to k times x. In this case, k happens to be equal to 13. So there's a little bit about direct variation. It has to look something like this equation here, or y is equal to kx. This last sentence is pretty important to understand. The variables y and x are said to vary directly with each other. Sometimes you're going to see that expressed as y varies directly with x. That's just another way of saying that y and x vary directly with each other. Another way to say it is y varies directly with x. So let's get into an example here. Our first example is an equation a direct variation. We're going to determine or answer this question: is each equation a direct variation? If it is, find the constant of variation. So two parts to this question. First, determine if it's a direct variation. To do that, and this is a note that is not on your note packet that you want to write down. I'm going to read it, and if you're watching the video, you may want to pause the video and write this note down. To determine if an equation is a direct variation, we want to solve the equation for y to put it into the y is equal to kx form, the form we just talked about. If we can put it into that form, then the equation is a direct variation. If we cannot put it into that form, then it will not be a direct variation. Remember, k is this constant of variation that we need to find if it is a direct variation. So let's take a look at our first example. Remember, to determine if this is a direct variation, we want to solve this equation for y. So we want to use our addition, subtraction, multiplication, and division rules of equality to help us do that. So we want to get the y isolated on one side of the equal sign. So we're going to first subtract this term 2x from both sides. When we do that, the 2x's on the left go away, leaving the negative 3y on the left of the equal sign. And on the right, watch how I write this. I have 1 minus 2x, but I'm going to rewrite that as this: negative 2x plus 1. At this point, you may realize that this isn't a direct variation. If you don't, let's take a look at exactly why. So finally, to isolate the y, or solve that equation for y, we divide each side by negative 3. On the left-hand side, the negative 3's divide out, leaving us with y. And y will be equal to, now when I simplify this side, this denominator can be split so it's written as two separate terms: negative 2x over negative 3. And then here, 1 over negative 3, or minus 1/3. Now this can be simplified right here. This term, the x term, can be simplified. It doesn't have to be at this point, but it can be. We could rewrite that as 2/3 x minus 1/3. Now that we have it solved for y, we want to come back to this form right here. Y is equal to k times x. Y is equal to k times x. Now, let's compare this equation solved for y. It has a y. It has an equal sign. In the place of the k is a 2/3, there's the x. But notice it has this extra subtraction term on it, this extra negative term, minus 1/3. This is what causes this equation not to be a direct variation. It's not y is equal to kx, it's y is equal to kx minus 1/3. So since we cannot put this equation into this form exactly, it is not a direct variation. Okay? So remember, given an equation, to determine if it's a direct variation, we have to be able to put it in this form. And this equation, 2x minus 3y equals 1, could not be put into that form. So that's going to be the goal here. Can we put this equation, 2x minus 3y is equal to 0, into the form y is equal to kx? So we're first going to identify what we want to solve for. We want to solve for y. So to do that, we subtract 2x from both sides. The 2x's on the left become 0. They cancel, leaving negative 3y on the left. And on the right, we have negative 2x. Next, we divide each side by negative 3. Same steps as we had in the last equation, but it's going to end up being a little bit different. The negative 3's on the left divide out, leaving y is equal to negative 2x over negative 3. Now, much like we simplified this fraction on the example A, we're going to simplify this fraction. These two negatives become a positive, and I can pull that fraction out, 2/3, and leave the x as the variable. Now I bring down my y. Now, if we compare it to the form for the direct variation equations, y is equal to kx, y is equal to 2/3, which is the kx. So we can take this equation that we started with, 2x minus 3y, use some algebra on it, and we can put it in the form y is equal to kx. And to answer the question, is each equation a direct variation? This equation is a direct variation. And its constant of variation, or k in this case, is equal to 2/3. Remember, to put an equation, or to determine if an equation is a direct variation, we have to be able to put it into this form, y is equal to kx. Example 2t, writing an equation given a point. Write an equation for the direct variation that includes the point negative 3 comma 2. This is a very easy thing to do. We're told that it's a direct variation, so we know we're going to be working with this equation y is equal to kx. This is the equation for a direct variation. What we do at first is we take this point negative 3 comma 2 and we substitute negative 3 and 2 in for the x and in for the y. So I'm going to write that point down over here. And we substitute these in. Remember, the first number is the x coordinate, the second number is the y coordinate. So when I substitute those numbers in for y I'll substitute 2. I'll keep k as it is, and I will multiply that by negative 3. After we substitute, we solve for k. We solve for the constant of variation. We solve this equation by dividing each side by negative 3. On the right-hand side, the negative 3's cancel, and on the left-hand side, we have negative 2/3. Bring down the equal sign, bring down the k, and what I'll do is I'll turn this around. So we find that the constant of variation, k, is equal to negative 2/3. So now that we have the constant of variation, we're going to reuse this equation for direct variation. Y is equal to kx. And all we're going to do is rewrite it and substitute negative 2/3 in for k. Y is equal to negative 2/3. So this is the equation for the direct variation of a line that goes through negative 3, 2. To review, what we did is we started with the equation for direct variation. We substituted in the ordered pair, the x and the y values. We solved that equation for k by dividing each side by negative 3. That gave us our constant of variation, k is equal to negative 2/3, and I substituted that in for the k, giving me my final solution, the direct variation equation, y is equal to negative 2/3 x. The last example is a real-world problem-solving situation involving direct variation. Let's read the problem, then we're going to break it down. The weight of an object exerts on a scale varies directly with the mass of the object. If a bowling ball has a mass of 6 kilograms, the scale reads 59. Write an equation for the relationship between weight and mass. First thing we need to worry about is the first sentence. We know it's a direct variation because it tells us it varies directly. Now, what varies directly? The weight of an object varies directly with the mass of the object. So we could break that down is that weight varies, not vary, but varies directly with mass. So weight varies directly with mass. That means from previous discussions when we've talked about dependent and independent variables, the weight depends on the mass. So let's define some variables now. We'll say W is equal to the weight, and we'll say M is equal to the mass. We're going to write our direct variation equation. Weight varies directly with mass. So weight varies directly with mass. Here's our constant of variation times M. The difference between what we just did and what we're doing now, instead of using x and y, we're using W and M. We're told in the problem that the mass is 6 kilograms. So in for mass, I'll put 6. We'll be multiplying that by k, and that the scale reads, or it has a weight of 59. We solve this equation for k, the constant of variation, by dividing each side by 6, and we find that the constant of variation is equal to 59 over 6. We take that constant of variation, substitute it back into this direct variation equation to give us the weight is equal to 59 over 6 times the mass. This is the direct variation equation for this problem, the weight compared to the mass of an object. I pulled this information from the first sentence. The weight of an object exerts on a scale varies directly with the mass of the object. The weight varies directly with the mass. The two variables in this problem are the weight and the mass. So I define those variables. Weight is W is equal to weight, M is equal to mass. I wrote this equation right here with a red star next to it. I wrote that equation from here. Weight now varies directly, kind of implying is the equal sign. This is my constant of variation, which I have to put in there, and then mass. Varies directly could really be this equal sign and this constant of variation. Okay, I substitute the weight in, I substitute the mass in, solve for the constant of variation, and then substitute that into the equation I wrote. Direct variation has to do with this equation right here. Y is equal to k times x. K will be the only number in the problem. Y is equal to k times x. That's direct variation. If you need more help, ask me for questions in class.